Another application of the tangent line is we will use the tangent line to estimate the zero of the function. So how would we do that? So consider the tangent line of f of x at x naught. And let's say here's our x naught. And let's go ahead and draw the tangent line to this point. The tangent line of this function at x naught. Note that the tangent line is intersect the x-axis at this point. We call this point is x1. And let's see what happens if we consider the tangent line of f of x to the point x1. So here is the tangent line of x1, of f of x to the point x1. Again, this tangent line is intersect the x-axis at this value called x2. Again, consider the tangent line to the point x2, the tangent line of f of x at x2. Note that the actual zero of the function is at 0 in this graph. Now note that as the each time we draw the tangent line, the intersection of each time we draw the tangent line is come closer and closer to the point where f of x equal to 0, right? So we can use the tangent line to approximate 0 of the equation. So let's go ahead and take a look at how do we do that. Let's try to create the formulas. So first we will guess a first approximation to a solution of the equation of f of x equal to 0. We don't know what the solution is, but we'll make a guess. So let's say first here I make a guess. This is when I make a guess, I choose this is x sub n. Now that's the case, then I can draw the tangent line to xn, right? The tangent line of f of x at xn. And this tangent line is intersect the x-axis, and I'll call this point x sub n plus 1. Now the equation of the tangent line that pass through the point of the tangent line at x naught, at x sub n, f of x sub n. So this point here is x sub n, f of x sub n, is given by the equation of y minus f of x sub n equal f prime of x sub n times x minus x sub n. Yeah? And this tangent line is intersect the x-axis at x sub n plus 1. So the tangent line intersect the x-axis at x sub n plus 1. So this point is, or the point x sub n plus 1, 0. I will replace this value into our tangent line equation, call that star. Star now becomes 0 minus f of x sub n equal f prime of x sub n times x sub n plus 1 minus x sub n. I'll solve for x sub n plus 1. So then x sub n plus 1 is equal to x sub n minus f of x sub n divided by f prime of x sub n. Okay, so that's how we get the formulas. We can find each point approximately using that formula. So let's see how do we find the how do we put this to use. Use the Newton method to estimate the zeroth equation given x sub 0. We'll find your answer to 4 decimal places. So let's start with f of x. Well, we know that f of x is equal to x to the third minus 2x minus 5. We find f prime of x. F prime of x is equal to 3x squared minus 2. And we want to find what is the next point where x sub 1 is, given x naught equal to 0. Okay, so x sub 1 is equal to x naught minus f of x naught divided by f prime of x naught. This equal to 2 minus f of 2 divided by f prime of 2. This equal to 2.1. x2 equal to x1 minus f of x1 divided by f prime of x1. That equal 2.1 minus f of 2.1 divided by f prime of 2.1. This equal to 2.0946. X sub 3 equal x sub 2 minus f of x sub 2 divided by f prime of x sub 2. This value equal 2.0946. Look like it convert to the same value. Let's go ahead and see what is x sub 4. X sub 4 equal x sub 3 minus f of x sub 3 divided by f prime of x sub 3. It also equal to 2.0946. So this telling us, well, this is a pretty good approximation for the zero of this function. So x equal 2.0946 is a solution to f of x. Let's take a look at the next problem. Here we have x to the 6 minus 2 equal to 0, and we are given x naught equal to 1. Another way of phrasing this problem is to find the sixth root of 2. Okay, that's another way of phrasing it. Yeah, go ahead and solve this. Okay, let's f of x is equal to x to the 6 minus 2. Then f prime of x is equal to 6x to the 5th. We know x naught equal 1. So x1 equal to x naught minus f of x naught divided by f prime of x naught equal 1 minus f of 1 divided by f prime of 1. And that is equal to 1.1667. X of 2 equal to 1.667 minus f of 1.667 divided by f prime of 1.667. This equal to 1.1264. Similarly, you can calculate x of 3. X of 3 is about 1.1225. X of 4 equal 1.1225. So this telling us that SID root of 2 is equal to 1.1225, or another word, that is f of x equal to 0, imply x equal to 1.1225. You can use the similar method to find a solution for f of x equal to cosine of x minus 1. The solution for this, x is equal to 0.7391 for f of x equal to 0. Now the next thing we have to do with the, let's call the warning. I want to show you something for the Newton method. The Newton method may fail to convert in some case. Hence you go from x0 to x1, then from x1 back to x0. So consider this function. If you consider, say, if you choose the x0 is this value here, then the tangent line to x0 is this, consider this tangent line. It intersects the x-axis at x1. Okay, but then when you calculate the tangent line at x1, it bounces right back to the intersect here as x0. So this happened in some case. What means you have to pick a different value. Okay, you need to pick a different value for x0 in order to make this work. You can have so for some function you have two different value. You have two different solutions, right? And if you pick, say for example, this is the root that you want to find. However, you pick the value of x0 is on this side. You may able to find a root, but it's a different root, not the one that you are looking for. So it also can happen in that case. So choose your x0 wisely. Okay. Consider the function f of x equal x to the third minus 2x plus 2. Let x not equal 0, show that the sequence x1, x2 fail to approach to a root of f. Okay. Let's go ahead and start with f prime of x. F prime of x equal 3x to the second minus 2. Okay. And if let x not equal to 0, so x1 equal to 0 minus f of 0 divided by f prime of 0, that equals 0 minus f of 0 is 2, divided by f prime of 0 is negative 2, that equal to 0 plus 1, so this is 1. x2 equal 1 minus f of 1 divided by f prime of 1, that's 1 minus f1 equal to 1 minus 2 plus 2 divided by 3 minus 2, that equal 1 minus 1 over 1. This equal to 0. So note that, so it bounces right back to x0. Okay, so x2 now become x0. So it bounces back and forth. It doesn't it failed to approach a root. So this here equal to x0. So when x0 equal to 0, the sequence x1, x2 fail to approach a root.